Hi, it's Mrs. Martello. We're going to continue working in section 7.1. I'm on page 360. So what we're going to do now is we're going to add and subtract polynomials together. Keep in mind that you need to remember what like terms are. So remember, in order for terms to be like terms need to have the same variable or variables with the same exponent or exponents. Okay, so keep that in mind. Remember that when you add or subtract like terms, you're simply going to combine the coefficients. You leave the exponents alone. You don't touch the exponents at all when you add or subtract like terms. Okay, you leave the exponents. Don't touch those exponents. All right, so let's take a look at some examples. We're going to look at example 4. It says find the sum. So we have this polynomial 2x to the third minus 5x squared plus x, and we're going to add it with this second polynomial 2x squared plus x to the third minus 1. Now we can do this in two different ways. We can do it vertically or we can do it horizontally, and that's totally up to you. When you do it vertically, I'm just going to show you what it looks like. It means you're going to line up the like terms. So the 2x to the third has a like term of x to the third because they have the same exponent. So we're lining up those. Negative 5x squared has a like term of 2x squared because they have the same exponent. We line those up. Then we have x. X does not have a like term in the other polynomial. So notice how nothing is lined up underneath the x. And then finally we have the minus 1 over here, which again doesn't have a like term with the first polynomial, so notice how it's not lined up. Now we can add these expressions vertically with the like terms. So 2x to the third plus 1x to the third would be 3x to the third. Notice we add the coefficients to get 3, but the exponent stays the same. It's still x to the third. Negative 5x squared plus 2x squared is negative 3x squared, and then x and minus 1. That would be the vertical method. Personally, I don't like to use this method. I think it takes too much time to rewrite it and line up the like terms. I like to just use the horizontal method and mentally regroup the like terms. In this example, they literally regrouped them, but I just do it in my head. So we're going to look at example B. We have 3x squared plus x minus 6 plus x squared plus 4x plus 10. Let's regroup it so the like terms are together. So the 3x squared has a like term of x squared. Those get grouped together. The x and the 4x, those get grouped together. And then the negative 6 and the 10, those get grouped together. Let's add them. So 3x squared and x squared is 4x squared. X plus 4x is 5x. Negative 6 plus 10 is 4. And that would be our polynomial just like that. Okay, why don't we try we're going to try one more like this. Let's take a look at monitoring progress number 8. That's over here on this side of the page. Monitoring progress 8. All right, we have b minus 10 plus 4b minus 3. Okay, so again, I like to just visually group them together and add the like terms. So I know b has a like term of 4b. I'm going to add those two together. That's going to give me 5b. Then I have negative 10 and negative 3. Those are like terms. Let's add them together. That would be negative 13 or minus 13. And that's it. That's all we have to do for that. Okay, let's take a look at example 5. In example 5, we are subtracting polynomials. So when you're subtracting polynomials, you have to be careful because it's adding the opposite. Okay, so to find the opposite of the polynomial, we're going to multiply or distribute negative 1 to each of the terms. All right, so let's take a look at this first example. 4n squared plus 5 minus negative 2n squared plus 2n minus 4. So instead of subtracting this whole second polynomial, what's better is if you take this minus and distribute it into each of these change the sign of each number and make it into a plus. So instead of minusing a negative, we're going to add positive 2n squared. Instead of minusing negative, doing a negative of 2n, we're minusing 2n, and then minus a negative 4, that becomes a plus 4. And let's combine the like terms. So 4n squared and 2n squared is 6n squared. Negative 2n doesn't have a like term, so it stays the same. 5 plus 4 is 9. Let's look at example B. They do it horizontally for example B. We have 4x to the second minus 3x plus 5 minus the quantity 3x squared minus x minus 8. So we're going to take this minus sign that's in the middle and we're going to distribute it to all of the terms in this second set of parentheses. Notice when I rewrite it, I'm going to drop the parentheses. I don't need them anymore. This first expression stays exactly the same. Now this is going to be minus 3x squared. Negative and negative make positive x. Negative and negative make positive 8. Now let's look at like terms. So 4x squared and negative 3x squared, that makes x squared. Negative 3x and x is negative 2x. 5 and 8 is 13. Let's do one of these examples together. We're going to take a look at monitoring progress number 10. So in monitoring progress number 10, I have p squared plus p plus 3 minus negative 4p squared minus p plus 3. So what I'm going to do first is I'm going to take this minus sign and I'm going to distribute it to each of these terms so that I can make this into an addition problem. I'm going to keep this whole first polynomial the same. Nothing changes. P squared plus p plus 3. Now let's distribute this minus. Negative and negative make positive 4p squared. Negative and negative make positive p. And then this would become minus 3. All right, now that this is addition, let's add together the like terms. This is a 1p squared and 4p squared. That makes 5p squared. Then this is a positive 1p and another 1p. That makes 2p. And then finally, this is a positive 3 and a negative 3. Those terms actually cancel each other out. So they are gone. I don't need to write it down. I could say plus 0, but I don't need to. I'm just going to get rid of that and have this as my answer, 5p squared plus 2. All right, so that's adding and subtracting polynomials. Let's take a look at a real world example. Here's example 6. So it says a penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the heights in feet of the objects after t seconds. So we have here is our first polynomial. Here's our second polynomial. Write a polynomial that represents the distance between the penny and the paintbrush. So if I want to find the distance between them, I'm really finding the difference between these two polynomials. So we're going to subtract these polynomials. So negative 16t squared minus 40t plus 200, and we're going to subtract it with negative 16t squared plus 100. Don't forget to distribute. This becomes positive 16t squared, and this becomes minus 100. This negative 16t squared and 16t squared actually cancel each other out. This is still negative 40t. Combine your like terms would be 100. So that's the polynomial, negative 40t plus 100. For part B, it says interpret the coefficients of the polynomial for part A. When t equals 0, so that means at 0 seconds, they're talking about the time. Time is our t. The distance between the objects, if we plug 0 in here and I plug 0 in here, I would just have 200. If I plug 0 in here, I would just have 100. So the distance between the objects is 100 feet. So the constant term 100 represents the distance between the penny and the paintbrush when both objects begin to fall. So notice how they used the new expression from part A. They plugged in 0 into here to just get 100. As the value of t increases by 1, the value of our expression that we found in part A here decreases by 40. So this means that the objects become 40 feet closer to each other each second. So negative 40 represents the amount that the distance between the objects changes in each second. All right, so that's just trying to understand what does this polynomial actually mean in terms of this situation.